Hi everyone, welcome to Vocal Academy. See in this problem, here how to find the current I, Vi and V0. Means the current I which was passing through the silicon diode and input voltage and output voltage drop across 1.2 kilo ohms. How can you find it? Here the current source is given, that is 10 milliamperes with having internal resistance, that is 2.2 kilo ohms. So it is nothing but the internal resistance which was connected to the current source. Now let's see here how to find it. So first of all we want input voltage. How can you find it? So for that I am going to use source transformation technique. So this is the source transformation technique. So here current with parallel resistor is there. Means the current I having resistor is there. So at that time it was replaced with a voltage source with having voltage that is equal to product of current into resistance, that is I into R, and resistance is same, that is R. Now replace these two elements with these two elements, then the circuit become like this. So grounds are connected, okay, remaining two elements keep as it is, that is diode and resistor, and these two elements are replaced with a voltage and resistor in series. So here this is silicon diode, keep as it is, and this is 1.2 kilo ohms. So in this we need current I, and here we want voltage V0, and this is the resistance 2.2 kilo ohms. Next voltage means product of current into resistance, it becomes, so kilo into milli means 1, so 2.2 into 10 means 22, that is 22 volts. Be careful, it is the internal resistance, so it is not the source voltage. So here the positive pin will be connected to the diode is positive, so negative will be grounded, means the diode is in forward bias. Now we can easily find current I in this loop, so then we can easily find the voltage, that is input voltage and output voltage. So let's see here. In this loop this is the source voltage, but it is not actually source voltage. So this source voltage acting having internal resistance, that is 2.2 kilo ohms. So that is according to KVL 22 volts equal to current I into, so here 2.2 kilo ohms according to Ohm's law, plus it was made with silicon diode, so voltage drop is 0.7 volts, plus and here current I into 1.2 kilo ohms. So by simplifying this we get current I that is equivalent to 6.26 milliamperes. Now you can easily find the input voltage Vi. So before going to that I am going to give one real example. Suppose you have $500 money is there. So due to some requirements, means internal problems in home, you are planning to give only $50 for charity. Only $50 will go to your requirements. So this is act as a source for the charity. So remaining will be as a internal problems. So like that, for this source this is the internal resistance, means some voltage will be dropped internally, then the remaining voltage will act as a source for these two elements. So first of all remove that internal drop. So in this 22 volts remove the voltage drop due to internal resistance, that gives the input voltage, that is input voltage equal to 22 volts minus the voltage drop due to internal resistance, that is 2.2 kilo into current I is 6.26 milli according to Ohm's law. So this is the voltage drop due to internal resistance, so remove it from the 20 volt source, it gives the input voltage, so that is equivalent to 8.21 volts. So this is the input voltage. Now how to find the output voltage? So in this loop the current I is passing in the 1.2 kilo ohms, because we want voltage drop V0 across this resistor. So V0 equal to, according to Ohm's law, current I is 6.26 millimeters 10 power minus 3 into this resistance, so that is 1.2 kilo ohms. So by using calculator we will get approximately 7.5 volts. So this is the output voltage, and this is the input voltage source, and this is the current was in the given circuit, and this is the process of simplification. Thanks for watching. Please subscribe, like, share. Thanks.